Okay, so today I'll be going over FRQ number 6 from the 2007 for Calc PC. So first, the problem tells us that there's a function f of x, which is equal to e to the negative x squared. So part A asks us to write the first four non-zero terms and the general term of the Taylor series for f about x equals 0. So for this, we need to remember that e to the x, the time component series or representation of that, would be x to the n over n factorial. And so if we write that out in four terms, it would be 1 plus x squared over 2 over 2 factorial plus x cubed over 3 factorial. X to the n over n factorial. This is the representation of e to the x. So to make this negative x squared, we would just substitute in negative x squared for x in this equation. And so writing that out, it would be f of x equals 1 plus, see we have a x, we put that in with a negative x squared, so it would be minus x squared plus negative x squared whole squared divided by 2 factorial plus negative x squared whole cubed over 3 factorial. And that goes on, and that'll just be negative x squared, negative x, all that to the n over n factorial. Yeah. So simplifying this out, you have f of x equals 1 minus x squared plus x to the 4th over 2 factorial minus x to the 6th over 3 factorial negative 1 to the n, because it's alternating, x to the 2n over n factorial. This will be your answer. And to get points for this problem, this is a 3-point part. It's worth a lot, so you should not miss it. And all these parts are really easy to do. The first part to get points is 1 point. You have to have written out your work and show your expansion and plugging in negative x squared like we did here. And the second part is showing the remaining terms, and then the third point is showing this general term right here. Okay, so now let's look at part B of 2007 question number 6. So part B is asking us to use your answer in part A, which we found the series representation of f of x equals e to the negative x squared for 4 terms. Use that to find limit as x goes to 0 of this 1 minus x squared minus f of x divided by x to the 4th. So this will just be direct substitution for f of x. We'll be plugging in what we found last time. And last time we found f of x to be, first let's just plug it in. Limit as x goes to 0, 1 minus x squared minus, and we found f of x to be 1 minus x squared plus x to the 4th over 2 factorial minus x to the 6th over 3 factorial. This is the 4 terms of the representation we found last time. All of this over to x to the 4th. And now you can easily see that this 1 minus x squared and this 1 minus x squared will easily cancel, leaving us with limit as x goes to 0 of, and because there's a negative still outside, you have to distribute that. So you have negative x to the 4th over 2 factorial plus x to the 6th over 3 factorial, all of that over x to the 4th. And now simplifying that further, you can cancel out the x's, and limit as x goes to 0 of negative 1 half, 2 factorial is just 2. You cancel out the x to the 4th with this x to the 4th plus x squared over 3 factorial, and since limit as x goes to 0 is just negative 1 half. This is a pretty simple problem, and for this problem you will be earning only 1 point for your answer. But good, so now let's look at part C. The question is asking us to write the first 4 non-zero terms of the Taylor series for integral from 0 to x of e to the negative t squared dt, and use the first 2 terms of your answer to estimate integral from 0 to 1 half e to the negative t squared. So if you realize that e to the negative t squared, we did the work for that in the previous problem. Integral of what we found in part A, which is 1 minus, instead we'll be using the variable t instead of x, 1 minus t squared plus t to the 4th over 2 factorial minus t to the 6th over 3 factorial dt. We'll be taking the integral of this. And so this will give us, so now we'll use FTC to simplify this, but since it's just 0 will not do anything, so we can just eliminate that term, just plug in x for t. So it'll be, and this is your 4-term Taylor series representation of this. But now just plug in 1/2 for x and solve. So doing that, but instead, remember, it's asked us use the first 2 terms, so we're only using these terms and plugging in 1/2 into those. I made that mistake when I was solving. So plugging in 1/2, you get 1/2 minus 1/3 times 1/8. That's just 1/2 cubed. 1/8 is 1/2 cubed. And simplifying this out, that's 11 over 24. So your answer is 11 over 24 for the estimation, and your answer for the Taylor series representation is right here. And so you get, this problem is worth 3 points. So you get 1 point for these 2 terms being correct, you get another point for the rest of the terms being correct, and you get another point for the estimation, 11 over 24 being correct. So now let's look at part D of the 2007 question number 6 FRQ. Part D is asking us to explain why the estimate found in part C, which is 11 over 24 for this value, explain why that differs from the actual value of this by less than 1 over 200. So we have to realize that we need to use the 3rd term of the representation we found in part C. Part C, the first part of part C, we found out that the representation of this was x minus x cubed divided by 3 plus x to the 5th over 5 times 2 factorial, which is just 10 minus x to the 7th over 42. So we found this as the representation, and we need to realize that 11 over 24 was the estimation for the first 2 terms, and because it's an alternating series remainder test, we need to use this 3rd term and plug in 1/2 and to this 3rd term to determine if this series is less than 1 over 200, or if the error for this estimation is less than 200. So plugging in 1/2 into x to the 5th over 10 will give us 1 over 320. And since this is less than 1 over 200, we can therefore conclude that it is less than. So for this problem, you will get points for 1, your explanation, and figuring out that you need to use this 3rd term. Okay, so now let's go over this style of problem. What was in this problem and the main key concepts, as well as places to go to practice these kinds of concepts. So first, the main concept that you really needed to know is to memorize your e to the x summation form, which is x to the n over n factorial. You also need to memorize cosine, sine, tan, tangent. And second is the alternating remainder series test, or the alternating series remainder test, which is in part D of this problem. It's really quite simple. If you don't understand the concept, then you wouldn't be able to solve part D whatsoever, and you'd lose 2 points. And so for practice, I would recommend looking at the textbook for Taylor-Maclaurin series. That would be chapter 11.10, 11.11, looking over those, and also looking at that table in 11.11, I think, or 11.10. It has a table of all the series representations for the main things like e to the x, cosine, sine, ln, and you need to remember these. And so look at that table for remembering these. And then for alternating series remainder tests, this would be a part of chapter 11 as well. I'm pretty sure it'd be 11.5. That's where you'd find alternating series remainder test problems.